For centuries, humanity has treated winter as an invading physical force. We have built shelters to hide from it, and we have harvested it from frozen rivers to pack into insulated boxes. Our language reinforces this idea every day. We tell each other to shut the window, you're letting the cold in, or we complain about a damp wind seeping into our bones. We speak about it like a fluid that pools in the corners of a drafty room. In the strict mathematics of physics, this substance does not exist. Cold has no mass, no volume, and no measurable energy. If cold is a complete illusion, we have to explain the physical reality of our senses. Something very real happens when an ice pack numbs your skin, or when a winter wind stings your face. To understand what is actually happening to your body, we have to look past our human sensory perception and examine the invisible one-way street that governs energy in the universe. Look closely at any object, and you'll find a chaotic swarm of atoms in constant motion. Everything we feel is dictated by this microscopic movement. What we call temperature is simply our macroscopic measurement of this activity. It tracks the average kinetic energy, the wiggling and jiggling speed of those specific atoms. When a hot object touches a cooler one, its fast-moving atoms violently crash into the sluggish ones. The slow atoms get knocked around and speed up, while the fast atoms lose their momentum and slow down. This specific act of transferring kinetic energy from the fast atoms to the slow ones is what physicists call heat. Heat is an action, it is not an object. Hold an ice cube, and the ice isn't pushing a substance called coldness into your skin. Your nervous system is sounding a painful alarm because the fast-moving atoms in your hand are rapidly bleeding their kinetic energy into the slow-moving atoms of the ice. This mechanical view of energy was formalized during the Industrial Revolution, as engineers tried to squeeze more efficiency out of steam engines. Early physicists like Sadi Carnot noticed a strict rule governing these machines. Heat possesses an inherent directionality. It only flows from a hot body to a cold body, never the reverse. This observation became the second law of thermodynamics, a principle stating that energy naturally disperses, and entropy, or disorder, always increases. It is why a jar of lukewarm water will never spontaneously unmix itself into hot and cold sections. The energy has already spread out, and the universe will not put it back. Because of this universal law, cold cannot flow into your body. It has no kinetic energy to give you. The universe mandates that your heat can only flow out. This raises an obvious question about modern cooling appliances. If cold doesn't exist and heat only flows outward, how do we chill our food? Refrigerators do not pump a chilled substance into an insulated box. They are heat engines running in reverse. This diagram shows a refrigerator cycle. It requires external energy, work, or W, to forcefully absorb kinetic energy, heat Q2, from the cold food. It then compresses that thermal energy and dumps it into the kitchen. That's why your fridge's exhaust coils feel warm. Even our most powerful cooling machines cannot create cold. They are simply mechanical thieves, using electricity to forcefully evict heat against its natural flow. If cooling is nothing more than the removal of kinetic energy from atoms, what is the absolute bottom limit of that process? In the 19th century, William Thomson, later known as Lord Kelvin, established a temperature scale based entirely on the presence of kinetic energy, rather than on our flawed human perception. As heat is continuously extracted, atomic wiggling steadily decreases until it reaches 0 Kelvin, or absolute zero, the point where all classical movement simply stops. You cannot have less than zero movement. There is no infinite cold, only a hard, physical floor of absolute, immovable stillness. This reframes our place in the physical world. Your body is not a fragile vessel fighting off the winter cold. You are a 98.6-degree biological engine operating in a universe that is mostly empty and still. The next time a winter wind hits your face, you aren't being attacked by coldness. You are feeling the vast, still universe quietly stealing your kinetic energy.